All right, next up we'll look at problem 7. This one's asking us to find the domain of a pretty complicated function here. So we've got f of x equals 3x plus 1 over the square root of x squared plus x minus 2. So if it's asking us to find the domain, we need to remember what domain means. Domain is all of the x values that make this function work. So really what we need to think about is what would make this function not work? Because then we can say the domain is everything except those values. So what could make a function not work? Well, the two most common things are having a negative number under a square root, because that takes us into non-real numbers, and having 0 in the denominator, because dividing by 0 is impossible. So probably 90% of the time when we're thinking about domain, those are the big things to look for. Square roots of negatives and 0 in the denominator. And we have the potential for both of those here because there's a square root and there's a denominator. And even more specifically, the square root is in the denominator. So really what we need to think about is this thing under the square root has to be positive because it's not allowed to be negative and it's not allowed to be 0. So really it just has to be positive, which that makes this pretty easy to consider because we have a way to say something is positive. We're just going to take that thing under the square root, x squared plus x minus 2, and say that it must be greater than 0. So greater than 0 makes so we won't have a negative under the square root, and it won't actually be 0. It's got to be greater than 0. So really this is just a quadratic inequality to solve then, and we can solve it by factoring. This would factor as x plus 2 times x minus 1. So if we just solve this like an equation, we would set each factor equal to 0 and figure out that x equals negative 2 and x equals 1. But keep in mind, we're trying to figure out where is the denominator greater than 0. At these numbers, it's equal to 0. So these numbers are actually not part of the domain. What we need to think about then is all of the other numbers. So we're basically going to divide all numbers into 3 groups. And I'll use a number line to show that. So think of a number line, negative 2 would be here, 1 would be here. There's essentially 3 groups of numbers that aren't negative 2 and negative 1. There's all the ones to the left of negative 2, there's all the ones here in between negative 2 and 1, and there's all the ones to the right of 1. We need to figure out which of those groups, if any, work for this function. The way we do that is just by plugging in one number from each group. So plug in a number somewhere to the left of negative 2. I'll just use negative 3. If I plug in negative 3 to this function, I want to see if that breaks one of these rules. So if I plug in negative 3 squared is 9, plus negative 3 would be 6, minus 2 would be 4. So I don't have a negative under the square root, I don't have 0 in the denominator. So if negative 3 works, that actually means that everything in this group will work. So part of our domain then will be everything to the left of negative 2. So we'll write that as negative infinity to negative 2. Let's check our next group, the thing in the middle, between negative 2 and 1. So we can use 0 in there. So if I plug in 0, 0 squared is 0, plus 0 is still 0, minus 2, that would give me negative 2 under the square root. That's not allowed. So this group of numbers actually does not work for this function. And then finally, let's check something to the right of 1. So I'll use 2. Plug in 2 to the function. 2 squared is 4, plus 2 is 6, minus 2 gets us back to 4. So it's not 0, it's not a negative under the square root. These numbers also work. So also everything to the right of 1 is in our domain. So from 1 to infinity. And then to show that it's both of these groups, we just put a U in between. That stands for union. It's the union of these two groups make up our domain. So our domain for this function is negative infinity to negative 2, union 1 to infinity.